17.
Wait, 9.
No.
Okay, then have that
Never mind.
situation.
Number 9. This is off of the chapter 2-2, 2-1 worksheet. This is very simple. What I need you to understand is that this is f of x is equal to negative x squared plus 25. Is this already in standard form? Yes. What does the negative do to the graph?
reflects it.
It reflects it over the x. What's the 25 do to it?
Puts it up.
Puts it up 25 units. Are we cold in here?
No, no, it's perfect.
No.
Leave it. Leave
It's
it.
like
This is perfect
-15
temperature.
in this one part.
Okay. So now this is standard form. So this is letter A. It's done. Letter B is what is the vertex? So what's the vertex here? Did I go up, down, left, right? I went up 25. What did I do? Left and right.
0.
0. So if I didn't move left or right, so my vertex for my left or my right value is 0. And then what did I do? Up 25. So now here's my vertex. Sorry. Because the left and the right is the x coordinate, and since I didn't move left or right, it's 0.
Oh.
Okay? Now letter C says to find the x-intercept. So this is 0 is equal to negative x squared plus 25. So x squared is equal to 25. How do I find it?
Oh, that's a big.
Take the square root. So x is equal to plus or minus 5. So that means I have x is equal to negative 5 comma 0 and x is equal to 5 comma 0. Those are my two x-intercepts. And this makes complete sense because now in my head, I can graph this bad boy. Here's the point 0, 25. And here's the point negative 5. Here's the point positive 5. There's my graph. You see
You
it?
have to draw that on a paper.
No, but by getting the x-intercepts and the vertex, I can have a visual immediately. I have 3 points. Right? Good? Okay, and letter D would be to graph it and make sure that you're correct. Any questions over that?
So, like, would 10 be the same as that?
10 is exactly the same way. 12 is exactly the same way. 17, f of x is equal to negative 3/5 times x squared plus 6x minus 5. What did I tell you guys to do with this problem?
Give it.
Chicken. What do I have to do? Why would I distribute? It's outside the parentheses, and I need to distribute this. Negative 18/5 x minus or plus, negative times negative is a positive. The 5's cancel out to give me 3. Now what do I do to complete the square and make this thing go in standard form?
That's the 2 plus.
Or perpendicular.
Sorry. Isn't it still shrinking?
Yeah, but it's not going to be, x squared isn't going to be singled out. Be in standard form.
To be in standard form means that I need to have an a value, an x value, or I should say an a value, an h, and a k. Right? Well, I'll still have an a. What is a? Well, a was negative 3/5. It's still going to be negative 3/5 at the end. How do I make this in standard form without dropping my a? I need to set this, take the constant over the other term, over the other side. So it's negative 3 is equal to negative 3/5 x squared minus 18/5 x. Now, my leading coefficient has to be what value? 1. So how do I make my leading coefficient of 1? By pulling out the negative 3/5. So if I pull out a negative 3/5, I'm left with x squared plus 6x. Do you see that the negative 3/5 is still there? I had to distribute that so that I could bring my constant term out of it and take it over the other side. I couldn't bring my constant term over without distributing that negative 3/5. Do we all understand that? Okay, so did I lose my A value? No, I did not. So now what do I need to do? Sidebar means I take that middle term and do what to it? So 6 divided by 2 gives me a 3. So what am I going to do with that value? I'm going to square it and add it to both sides. So what did I add to this actually? Exactly, I'm only adding it to the right side right now. So what did I actually add to the right side of the scale? I have negative 3 plus a negative 3/5 times a 3 squared. Do you see that that's exactly what I added to both sides with the equal sign? And the reason why is because I added 3 squared inside of parentheses. Those parentheses are being multiplied by negative 3/5. So I'm not just adding a 3 squared, which is a 9 on both sides. I'm adding 3 squared times negative 3/5. Do we all understand that, yes or no? Okay, now with that said, I need to go ahead and calculate this. So this gives me negative 3 plus. This gives me a 9. 9 times 3 gives me negative 27/5. Negative 3/5 here, times, what do these three terms turn into? X plus 3 squared. Okay, now, this negative 3 turns into what? Number 1, so that's going to be negative 15 over 5, correct? What's negative 15 and negative 27? What is the negative 15 and negative 27? Negative 42 over 5 is equal to negative 3 over 5 times x plus 3 quantity squared. Am I done? No, because I need it in standard form. What's standard form? So 0 is equal to negative 3/5 times x plus 3 squared plus 42 over 5. This is my standard form function. In other words, what I was given at the beginning, these two are equivalent. Now from there, what do I get out of it? What's my vertex? This is letter A. Letter B is my vertex. So what's my vertex? Very good. I'm at negative 3, positive 42 over 5. Now what do I need to do next? I need to find the x-intercept. So I'm going to cheat. I'm going to take this one right here. And I'm going to copy that. Okay. I need to solve that thing for x, don't I? So how do I solve that thing for x?
Why did you go back to that?
Why did I go back down? Because by definition of an x-intercept, it is the point where it's going to make it equal to 0. Well, if I make this equal to 0 and solve for x, I'm still going to subtract 42/5, aren't I? So I may as well take this step right here, right? Saving myself some time. Okay, so now, talk to me about those fifths. What happens to the 5? Why? You multiply by both sides by the reciprocal of 5 over negative 3. And what happens up is the 5's cancel out and the negatives cancel out. Do we see that? Right? And so what you have is 42 divided by 3. What is 42 divided by 3? Nope. 14. That's okay. And that's gone on the right-hand side. And what are you left with is just x plus 3 squared, right? Now what? Sorry? Nope.
Square root of x plus 3 squared.
I'm solving for x, so I have to take the square root of both sides. So I have plus or minus the square root of 14 is equal to x plus 3. Right? What am I solving for? X. So this is going to be negative 3 plus or minus the square root of 14 is equal to x. So now Letter C,
Where's that -3?
my x-intercepts are going to be -3 plus the square root of 14, comma 0, and pod -3 minus the square root of 14, comma 0.
Okay, I'm totally starting now.
Yeah.
So I like Jack.
Well, good to know that you jacked it now rather than later, because tomorrow we're having a quiz over this.
Yippee.
The quiz will be exactly like something that I just did right here. You'll have to find the standard form. You'll have to find the vertex. You'll have to also find the x-intercepts. Are there any questions? It will be a calculator quiz. Okay. Any questions? Are we good?
This question alone took us like more than half.
I know, no whining about it.
I'm not whining.
You're taking it back.
Yes.
Fact has been noted. Okay. Now, with that said, did I pass out notes for 2-2 yet?
You might have straightened it out.
You just said 2-2.
Here we go. For section 2-2. I believe this is easy.
You've also been in college.
Is it easier than what we just did?
Okay. I printed off the notes for you. I can't get it any easier than that for you guys.
Thank you.
Thank you.
Well,
Keep up the good work.
okay. Chapter 2-2, polynomial functions. A polynomial function is any function in the form of x equals x to the n. It's also known as a power function. X squared, x cubed, x to the 4th, x to the 15th, x to the 22nd. Those are all power functions. Everybody with me on that? Okay? Now, if n is odd, then the graph is similar to the parent function x cubed. What does this mean? X cubed, there are two graphs of it. X cubed looks like what? It's a spaghetti function. Meaning, it looks like a piece of cooked spaghetti thrown up against the wall, correct? Another graph of x cubed is going to be something that looks like that. Okay? Now, how can I tell you that these two graphs are essentially the same parent function? This crosses the x-axis how many times? Once. This is what we call a repeated root. This crosses the x-axis how many times? 3. 1, 2, 3. This tells me that it is degree 3. However many times it crosses the x-axis tells you how many times it's going to actually be, what degree it is. Now, there are some issues going on there. What I said is not 100% true statement, because in the event that you have repeated roots, then you're going to have some issues. Okay, and we'll talk about that here, this chapter. Okay, what I want you to know is anything that looks like has an odd root is going to look like these two functions. Okay, now, the graph is similar to, if it's even, the graph is going to be similar to x squared. Okay, well, let's talk about that. An x squared function. It's like this. Yes? Again, how many times does this cross? Once. What does that mean? It's a repeated root. Whenever I say repeated root, that means it touches the x-axis and then turns at that value on the x-axis and changes direction. That's what a repeated root means. Okay? It touches at something and then changes direction. What you're going to say, Mrs. Yoder? Just touched it and then look what happened. It changed directions. Okay? Now, it is an increasing function the whole way, which is kind of looking like we can do this not really true. It is, okay, in this regard. Well, what's this one going to look like? How many times does that cross the x-axis? Twice, the x-axis. Not the y, the x. It crossed 2 times. Do we see that? This indicates that it's x squared, meaning its degree is 2. Do we understand that? Okay, well now let's look at the function x to the fifth. X to the fifth is going to look like that. It's going to be a straighter piece of a graph. Whereas the x cubed graph is going to have a more curve to it. Do you understand that? The x cubed graph is going to have more curve to it. X to the fifth, it's not going to have as much curve to it because if I take 2 and raise it to the fifth power, what value is that? 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. So I'm going to map this 2 value to the value 32. That's going up very fast, isn't it? Okay, do we understand that? So it's going to not have as much curve to it. Another way this thing is going to look. How do I know that that's x to the fifth? Sorry? 1, 2, 3, 4, 5. It crosses 5 times, right? Do we see that? So that's degree 5. Okay, does that make sense? Yes or no? Leading coefficient is the number in front of the highest. The leading coefficient is the number in front of the variable with the highest exponent. Number in front of the variable with the highest exponent. That's what the leading coefficient is. The degree indicates the number of zeros or x-intercepts the function has. The degree is the highest exponent, something you should already know also. Then here's the important thing. X-intercepts, zeros, factors, solutions, and root. Those are all exactly the same thing. So whenever I say I need the x-intercepts, and I'm talking to Morgan, Morgan needs to say, oh, well, she wants an x-intercept. Well, Jet says, let's find the zeros. But she said x-intercepts. Well, x-intercepts and zeros are exactly the same thing. Okay, do we understand that? It's no different than you having a nickname. Okay? This just happens to have several nicknames. Do we all understand that? Yes or no? You will have as many zeros as you have degrees. So therefore, what can I conclude about this lovely little thing going on here? There's 3 zeros. Why is there 3 zeros? Okay, so I know immediately I'm going to have 3 zeros. Because my highest exponent is 3. What else do I know? What's the function look like? Is it going to look like the one piece of spaghetti? Is it going to look like this one, the black graph? Which one is it going to look like? The green graph or the black graph? Why is it going to look like the black one? Because there's a whole bunch of junk attached to that there, isn't there? It's just not x cubed. It's got a whole bunch of other degrees added to it there, which changes the dynamic of the graph. But again, what you need to understand is it's still crossing it how many times? 3 times, which means you're going to be able to see a lot of information about that. Now, what else can you conclude about this? Leading coefficient. Leading coefficient is what value? Leading coefficient is a 4. Now, I want you to think about that. Well, I want you to think about the stretch, reflect, and all that jazz. Stretch, reflect, and compress. Okay, what's happening with that 4, the compression? What's happening with that 4? Is it being reflected? It's more of a stretch, right? Okay, so we know if this is more of a stretch and it's positive 4. What does the parent function x cubed look like? If I have x cubed, it looks like this. If I have negative x cubed, it's going to look like this, correct? So you tell me, what does this graph look like? The top one or the bottom one? It's going to look like the top, except for it's going to have how many times crossing the axis? 3, okay? That's a lot of information that you can pull from the graph. Now, what you have come up with is the leading coefficient test. The leading coefficient test talks about, your goal is to say graphically, what does the end behaviors of a function look like? Whether or not I know what it looks like, I can get a pretty good guesstimation of what it's going to look like on the graph without physically touching the graphing calculator, right? So what we're doing is we're estimating the rising and the falling of the far right-hand behavior of the graph and the far left-hand behavior of the graph. Do we understand that, yes or no? Y'all got me on that? All right, if n is your degree and n is odd, then we know that it's going to look like the function x cubed, correct? Well, we need to think about what a is. A is your leading coefficient. So what this means is if a is less than 0, it's going to look like the reflected x cubed function, correct? Because this is what y equals negative x cubed looks like, correct? So if a is less than 0, it's going to fall to the right and rise to the left. Do we see that? The left hand is increasing while the right hand is decreasing. Do we understand that, yes or no? Okay? Now, if it is positive, meaning greater than 0, meaning it's not been reflected, then the left-hand side of behavior this time is going to fall, and the right-hand side of behavior is going to rise. So what am I looking for today? What are the two words? Rise and fall, right? Left and right, rise and fall. You have to be able to determine what's going to happen to that. So if we go back to this lovely example here, is A positive or negative? A is positive 4, which means that's greater than 0, so what does that imply? What's the right-hand side doing? It's rising. What's the left-hand side doing? It falls. Do we understand that? That's all you have to write. That's all you have to know. We get that, yes or no? Okay, now what if it's an even function? If it is even, that means it's going to look like what function? Like x squared. And if it's going to look like x squared, okay, if a is less than 0, well, we know that that looks like negative x squared, correct? Because I'm reflecting it, meaning I'm multiplying it by a negative value. That means both of them are going to fall. If I have just x squared, or x to the 4th, or anything like that, that means they are both going to rise. Do we understand that, yes or no? Okay, so now let's talk about this. I'm going to put a negative in front of that. If I have negative 2x cubed plus 3x squared minus x plus 4, what does it look like? Tell me, what can you get out of this, Steph? Yes, negative 2x cubed plus 3x squared. Change that, I'm going to put it as negative. Tell me. It's going to be reflected, so what it looks like, negative x cubed, right? And more importantly, what else are you going to notice? What? So I have 3 zeros, 3 x-intercepts, or 3 factors, whatever you want to refer to them as. So it has 3 zeros, meaning it has 3 x-intercepts. Okay? More importantly, that means I'm going to rise over here. Do you see the picture of the graph? Why do I know that? Why do I know this? Because my leading coefficient is what? Since my leading coefficient is negative 2, that's less than 0, so that means my right-hand side is doing what? What's my right-hand side doing? Falling. And what's my right-hand side? Sorry, I said that backwards. No, right. My right-hand side is falling, my left-hand side is rising. Do we understand that? Okay? Get your books open. Tonight's homework is 1 through 12 all, and 17 through 24 all. Whoa. Did you see this? Now, for problems 1 through 8, are we listening? Problems 1 through 8, it says match the polynomial function with its graph. What would be really important for you to do? Get your books open to page 108 would be the first wise thing to do, and share with a friend.
Ask him to
bring it.
I glared at her in a second yesterday because I'm a whisper.
Number 1, what degree is it? Number 1, what degree is it? Degree 1, so how many times should it cross the x-axis? Number 2, what degree is that? 2, how many times should it cross the x-axis? 2, number 3. 2, number 4. 3, number 5. Page 108. Number 6. 3, number 7. Number 8. Now, those are all going to be dead giveaways. That's how many times it's supposed to cross the axis, right? Then you need to look at the leading coefficient, determine if it's positive or negative. Any questions over that? To match the graph. Okay, 9 through 12. It says sketch the graph of x to the n, and then each specified transformation. All I want you to do is tell me up, down, left, right, stretch, reflect. I don't need you to sketch it. I don't need you to sketch it. I need you to tell me up, down, left, right, stretch, reflect. No, because it's a parent function. You should already know. Does that make sense? Do we all understand that? Yes?
I get that. I'm not so sure about that.
17 through 24.
We're not there yet. Are we good on 9 through 12? Okay, 17 through 24. It says use the leading coefficient test to determine the right hand and the left hand behavior of the graph of the polynomial function. So what are you looking for here? Is it even or odd, the degree? If it's odd, that means it looks like what function? X cubed. And then you're going to look at the leading coefficient. Is the leading coefficient greater than or less than 0? If it's greater than, then that looks like x cubed, meaning the right-hand side rises, the left-hand side falls. Okay? What you're literally doing is applying this right here. That's it.
So even ones look like the x squared and odds look like x cubed.
Any questions over the homework for tonight? It is a very simple homework assignment. It is not difficult. Are we good to go?
Well, wait, if it's something to the 6th power, how's it gonna look like x squared off the x-axis?
Okay, good question. If I have x squared, it looks like this, right? If I have x to the 4th, it's going to look like this. It gets flatter, okay? It gets flatter. If I have an x squared that looks like this, it crosses 2 times, right? If I have an x to the 4th, it's going to look like this, right? And it's going to cross 4 times, look like a W or a what? If it's reflected, it could look like that. Okay? Both of them are rising because that means A is greater than 0. Both of them are falling because its A value is less than 0 because it's been reflected. Do we understand that? Okay. You guys have plenty of time to get started on tonight's homework. I want you guys busy the rest of the period. No talking. Am I clear?